Okay, here we go. Let's start. So today we have min stack, maximum subarray, and search interval. Let's see how we can solve this together. Hello Aya, Cindy, Harp, Jalas, Joel, John, Cleab, Marvin, Minatella, Mika, Mambi, Oluwatobi, Pascal, Ricky, Sabah, Sir Mbank, Somzi, and Yaninti. Sorry guys if I butcher your names. So we normally start from the first one, but I think today it's better to start from this one, because if we lead this one to the end, it's gonna need more energy. So let's start with the monster first. Okay, so insert interval. You can find the link here if you wanna check it out in your laptop. So let's start reading this and see what it is about. Okay, description. So you are given an array of non-overlapping intervals where intervals e start zoom a bit where intervals e start end, okay, represent the start and the end of the e interval, and intervals is sorted in ascending order by start. You are also given an new interval that have start and end, that represent the start and end of another interval. Insert new interval into the intervals such that intervals is still sorted in ascending order by start, and interval still does not have any overlapping interval. Merge overlapping interval if necessary. Return intervals after the insertion. Okay, it's a bit hard to understand what they are trying to say. Let's look for the example and see if it will make it clear. So we have intervals. This interval is array, and it have many interval inside. So this one from 1 to 3, this one from 6 to 9. And then we have another new interval that we need to insert inside these intervals, and it's gonna become 1 5 6 9. Okay, how did they do that? Let's see this one, how it's become like one copy. How did it become 1 5 1 6? So we have 1 3 1 3, then we have 6 9, and then we have 2 5. This is the new one, 2 5. Now 2 is somewhere here, and 5 is somewhere here. So it's like our interval is here. 2 5. Now we can't do 1 3 2 5 6 9, right? Doesn't make sense, because this one ends in 3, this one starts with 2. There's an overlap. So somehow the overlap become 1 5 6 9. So it's kinda like if they push this one down right here, and this one become 1, and this one become 5. 1569. So because there was a overlap, then they merged. It will become 1569. Okay, I hope this one clear. Who have like question about this example? Anyone have any question? We are still trying to understand what's the problem is. Let's see second example. So second example, they give this array that have many intervals, and they told us add 4h at this interval inside, and then it should give us this. Okay, let's do the same. Let's do the same, see how it become like that. So we have this. Okay, so 1 2, we have 1 2, we have 3 5, we have 6 7, we have 8 10, and the last one is 12 16. And they told us add 4h. So 4h, if we say 4h, it's gonna be somewhere here, 4, and 8 is gonna be here. Okay, so we can put it like this, 4h. So this one is clearly is not overlapping, so we're gonna keep it. It's gonna stay 1 2, but this one is overlapping. So how do we merge overlap? We did see this one in one of the previous problem that it was about interval. You take the main of the one that you want to add, or like the one that you want to merge, with the other one, the main of them, and you take the main of them. Here, the 3 and 4, the minimum number is 3, so the new merge is gonna be 3. And let's see where the interval finish. 5, no, because 5 is less than 8, 6 is less than 8, 7 is less than 8, so we can put 8. But if we put 8 here, we're gonna have another 8 10, which doesn't make sense. It does make sense sometimes. It depends on the problem, because some problem they might allow this to have. So like if you have this problem, you need to clarify with the with like the interviewer or who give it the problem is the interval can start from the end of the previous one. But Manion current, you have like a noise in the background. Please mute the mic. In our case, we're gonna just assume they are not. This is not our case, so we're gonna merge them, because I noticed also in the output they merged them. So because this also overlap, we're not gonna stop here. We're also gonna merge it with this one. So we're gonna take the end with the end of the last one that we're gonna merge. So which is the bigger number is 10. So it's gonna be 10 here. 10. And then we're gonna add the last one, which is 9, 12, 16. So basically it's like we push this line, we push it down, or like we push it up. Now it's become 1. And it's become 1 with this. We remove this, It's become something like this. So they give us array of intervals and give us a new interval that we want to add. and then we need to find a way to add it in a way that there is no overlap. Okay, who have any question about the problem? If you didn't understand, before we go to brainstorm idea how we can find solution for this. Any idea or any question?
Sorry, can I say something, please?
Yes, please go ahead.
So, in essence, what you're trying to say is if the starting point is an overlap, we get the minimum. Then the ending point, if there's an overlap, we get the maximum. Is that it?
Yeah, in the immersion, yeah, that's what we do, right?
Starting, that's what we're doing. Yeah, nice. Thank you.
Okay, I guess any other question about the problem? Who didn't understand what we're doing? Or what is the problem? Don't be shy. Just open mic, talk, or write in the chat. So I guess everyone understands the problem. Now, how do we can solve this problem? Let's see what is the function they give us. This one, insert. Okay, let's brainstorm. What do you think, guys? How we can solve this? What's your suggestion, solution? How do we think about this? Let's say we're gonna solve this problem. Any suggestion? I'm sure there's many ways to solve this problem, but you can choose one and just go with it. Okay, let's brainstorm. So we have array. This array intervals, this one right here. It have array 0, 1, 2, 3, 4. And then we have a new array, this one right here, that we need to add it here. So we're gonna be adding something inside this array. How are we gonna do that? Okay, no idea. Come on, guys. Someone has some idea. I already did this task, but I want to see if there's other idea. Yes, go ahead. Someone said something.
So I have a suggestion for this.
Yes, please.
So array of intervals, and then we're supposed to add in a new array.
Yeah.
That possibly overlaps with all some of the other arrays. So what we're going to be looking at mainly is we look through the intervals array, the one that is already given to us. Then
this one, yeah.
Checking the array, we check each of the intervals to see where the overlap begins. So for example, I check the 0, that's the first index. And on checking the first index, I see that 4, that's the 4 is not in between 1 and 2. So I check the next index if 4 is in between 3 and 5. So I think we'll be looking at something like binary search.
Looking for something what?
Like the idea will be something like a binary search of some sort.
Binary
so you start from the middle, then you check. Then if the first what's it called? If the first element of that list that you are on, say for example 2 is the middle. So the first element is 6 and is greater than 4. So we check back. So we do another binary search, check the middle, and we see that okay, this 3 is less than 4, and that means it overlaps with that 3. So we know that. Then for the next one, we check with 8. Then you do another binary search again. And then you know that for that binary search, where you check, you know that 8 is on the next side. So it's greater than the middle one. So we're checking the next, what's it called? The higher value of that array. So when you check with it, if it's higher, we check the right or the left. So we check the left, and then we get to the middle again. So 10. And when you check with 10, you see that it overlaps there. So it's 8, 10. Then you now, I think you have to save those points, then merge them, or pop all those lists, append append the new range, that's 3 to 10, in that place.
Okay, I did follow with you, but it was hard to imagine how binary search will work in this array. How do we gonna have like 2 pointers? Or like
The way I'm even looking at it is something like 2 binary searches.
so
One for the minimum of the integer and the interval, and one for the maximum of the interval.
okay,
Just
like
to
if we
narrow
wanna
down,
write
instead of
pseudocode,
going
how do we start? If we wanna write pseudocode for this. So we know this is our interval. Now we wanna add it.
Yeah.
Now we gonna what? Using binary search, how we can do? I still don't get it.
So we take the minimum
Minimum of all of them.
of the new array that we want to add. No, the minimum of the new array we want to add.
So we're gonna take
Then yes, that would be the value we're checking, all the minimums of the values in.
Okay, so we're gonna check all of the main. So we're gonna check 1.
Yes.
Check
Find
3.
the one that it overlaps with. Yes.
Okay, so in this way we are assuming they are overlapping.
Yes.
What about the case where they're not overlapping?
Then if it doesn't overlap, we then check for the maximum to see if that one overlaps. So if it doesn't overlap, we just append it into the list at the point.
Okay, like, do you want me to give you Excalibur? You wanna like explain it in Excalibur?
Will it work?
Like
the other time we can share it.
Yeah, or you wanna share screen if you want. If you wanna like if you wanna explain it, because I failed to follow up with the. I couldn't imagine it.
Yeah, it's just off the top of my head too. So,
Okay. Okay, I tried to see how it works, but I didn't understand how binary search will work in this case. I don't know.
Sorry, can I suggest to? Can I try?
Yes, please.
Okay, I know there are many solutions out there, anyways, but let me just try something. So I'm thinking that we should first, like he was trying to say, take the first index there, the first one, make a comparison with each of the lists in the array. So it's going to be something like something less when it's less than the first, and when the first index is less than this, which 4, and 4 is also less than the next one. So we are just comparing with each of the values there, 0 and 1, 0 and 1. We're comparing it. So if we find an overlap, we should find a way to indicate the index where the overlap happens. Like we have to kind of indicate, okay, there's an overlap here, so it has happened at this point. So we need to get the minimum to to ascertain the starting point. Then we add the minimum to a new list. You get. So we now pick the second one, which is 8, and we go again and move through again to check to see where the overlap is for the ending points for this particular list again. So when we indicate that where we find the overlap within the list, we indicate the index as well. So we add that to the new list. Then we continue with the rest, adding each of them as we go in the loop. So that's what I'm trying. That's my suggestion.
Okay, I kind of saw what you mean. I think that will work. So like we're looping on each array, and we see if it is like so let's say this is for 8.
Yes.
For 8. So we're looping and see if it is like overlapping with this or before it or after it.
Exactly.
Something like this. So if it was before it, we're gonna add it here. If it was after it, we're gonna add it here.
I don't think you get me though. No, that's not what I meant.
Okay.
I mean, you are picking them. You're picking there's a starting and ending point in the interval. You get. So starting point is 4, ending is 8. So we pick 4, which is the first one. We check for the minimums. You get. So we get the minimum, and when we find the minimum, we indicate where we got it, the index at which we got that minimum. Then we add it to a new list. We add the minimum of the 4. Maybe it's 4 and 5, or then we check the minimum between 3 and 4.
Oh, we create a new list.
A new list, exactly.
Okay, I see now. So in this case, we're gonna compare 4 and 8. We're gonna do 4 compare with, so like we wanna see, are we gonna add 1, 2?
Exactly.
Or we wanna add 4, 8 first? Or we wanna add 1, 2 and then 4, 8? So we wanna.
I don't think you add 4, 8 yet until you compare it. It's when you are satisfied that it's okay before you add. Like you can't find, if you check 4 now, 4 is not between 1 and 2, so we add 1 and 2. So 1 and 2 is fine.
Yes, but how are we gonna do that? We need to compare, right? Because if we have 0 and -1, we need to add it first, right? It's gonna be 0 -0, then 1, 2, right?
Yes, exactly.
So we need to. How do we know this one is before this or after it? Or loop. So we compare the edges, right?
Exactly. So yes. You compare
if this. Okay, let's do example. Here is 1. Here is 1 here, 1 before. So if, and this one is after. So if this less than this, if the start of the new interval is less than this, we know it's gonna be before it. But if the start is greater than this, we know that it's after it. So we're gonna compare 4 with 2. If 4 less than 2, we know that it is before it. But we also need to know, maybe it is before it, but this one is overlapping here. So we need also to check this should be less than this. If this one here, if this one is less than this, then it definitely before. If this is greater than this, then it definitely after. And then we're gonna keep looping on each one. We know where to add it. So for example, for 8, let's do a simple example. Let's do 1, 2, 3, 4, 4. Let's do here 4, 6, 7, 8, 10. Let's remove this one. Let's say we're gonna add 6, 7. 6, 7. So we're gonna loop and compare. We're gonna compare 6 with 2. Is it less than 2? No. Then we understand, because this is sorted, so we understand this is after this one. So we're gonna add 1, 2, because we are sure it is in the new list that we're gonna send. We're sure that the new array that we're trying to add is after the 1, 2. Then we're gonna go to the next element, and we're gonna try to compare again. Same thing. Is 6 greater than the end? The start of the new element greater? Yes, it's greater. So we know that 6, 7 is somewhere after this. So we're gonna do 3, 4. Now we're gonna come to this one, and we're gonna do, is 6 greater than the end? Uh-oh, it's not. So we know that 6, 7 is somewhere between here and here. Okay, so the first check is fail. Now we need to create a new check. We need to know, do we add it between? Do we do like something like this? Do we do like something like this, space like this, and just push this here? Just push it directly. Now, what is the check that will give us this? It's the same, right? We're gonna compare. The first check, when we were comparing the start with the end. Now we're gonna compare that after this first check that failed, comparing start with the end. Now we're gonna compare the end with the start of the element. So we're gonna see, is 7 less than 8? So the end with the start of the element, or the interval that we're comparing with. Because 7 is less than 8, then we're gonna push it here. 6, 7, and then
sorry. Yes. Sorry, can I cut you a bit? Sorry. I remember when we were testing when we were doing the first analysis, the first time you were showing it, we checked the 6 with the minimum. That's the minimum between 6 and 8 is 6. That's correct. You add 6. Then we checked 7 with the next one, which is 10. I don't know if I'm making a mistake there. You get?
We check 7 with 10.
The maximum. We need to get the maximum between 7 and 10. So that has to be 10.
Yeah, that's in merging, when we have overlap.
That's merging, exactly. That's when you're merging it. That's what I'm saying. Okay, you mean there's no overlap?
Yeah, there's no overlap because 3, 4, 6, 7. Yeah.
Okay, 7,
I think
7,
if we understand with no overlap, then we can add overlap after. Now in this case, we're gonna add 6, 7.
Yeah, thank you.
Because the first rule, it can allow us to add the elements that already exist in start. The second rule gonna allow us to add the element before the element that we're comparing with. Now what's gonna happen? We keep looping? I guess if we add the elements, we don't need to keep looping, we just need to add this part here. But we can keep looping. Let's say if we loop, again we're gonna compare. So we're gonna add this. and then somehow we need to add this too. So it's like, yeah, we're gonna add them both. So we can add 8, 10, and then we loop again, and this gonna be compare with this. I don't know. I think when we add this, there is no need to compare or something. We just need to get this part of array.
Exactly. Once you've added it,
yeah,
add the rest. Exactly.
Yeah, we can slice the array maybe and add all the parts that after. So automatically it's gonna add this. Now this is when there is no overlap. Simple number, we add it in the first. It's gonna also work if we wanna add something in the beginning. Now when there's overlap, let's see how it's gonna work. Let me copy this, put it here. Now if there's overlap, let's create overlap. I guess this is example they give us. I already have overlap. Let's work on it. Let's try again. So we have 1, 2. And we have 3, 5. We have 6, 7, 8, 10, 12, 16. Okay, now this set add this number for 8 to this one. Now we know there's overlap, so if we remember the rules that we set up at the first rule was compare the start of this with the end. What was the rule? Start of this with the end of this. So we're gonna see if we're gonna add this one. So we're gonna compare the start of this. I'm gonna keep it with color red, so it say that, and the end of the green end. Because if I compare the start with the end, it's like if the start is less than the end, that mean oh, greater, because
it's greater.
Great. So if the start is greater than the end, then we know this element. I hate this this thing right here. Like, why it show up? It's crazy. Oh my god. Okay, let's do like this. Okay, so if the, oh my god, please don't show. Okay, so F4. Okay, you know what? Let's just work with this half. F4 greater than the end of this, then automatically we understand that this interval that we're gonna add is far away from the first one. So the array that we're gonna send at the end of the program, it's gonna have this at the start. So 1, 2. Right? If it's past this condition, correct. Which is, so if it is the start bigger than the end, we're gonna append. Let me write it. Append interval. Okay, we're gonna call this interval, and this is new interval. Append interval, which is gonna be here. Now there is a second rule that we found, which is we're gonna push this one before this one. For example, this is 8, right? Let's say this is just example. I'm gonna break this. If this is 9 and this is 10, and I'm comparing this with this, automatically I understand this is before this, so I need to push this to the array before I'm gonna push this, right? So how we can do that? Again, it's same comparison, but this time we're gonna compare the end with the start. So the end, if the end is less than the start, if it is less than the start, then I need to append this one. So I'm gonna append not the interval, I'm gonna append the new interval, which means I'm gonna add it to this array because I know for sure this one is less than this. So it's gonna come to the array. This way it's gonna be like 4-8. But this is not our case. We're just like seeing these two example. Now this two example is simple. It's either gonna add the interval or the new interval, but we're gonna go to the case where we have overlap. So let's go back to that case. So overlap. We have 3, 5 here. 3, 5. So we need to find another case here. Case for overlap. Now we're gonna do simulation for both cases and we see when there's overlap what to do and how to detect it. Okay, so they give us this number 4-8. Let's merge it with this. We're gonna start from the beginning. We're gonna see the first rule. We wanna add something here that now we don't know. Do we add this number or this number? So we're looping on this array and comparing, looping and comparing with this. Now we are here. What do we add? Do we add this or this? Or no one of them, or we merge them and we add the new array. Now we're gonna compare start of red, which is this one, with the end of this. So 4 is 4 greater than 2. Yes. Append interval. Okay, so interval here is 1, 2. 1, 2. We move to the next element. We're gonna do the same check from the start. Start of the new interval is greater than the end of the interval. So the start color red with the end. Is it greater than the end of the interval? No, it's not. They are not. Okay, so this check is failed. Let's go to the second check. We are still in the same loop. Second check is the end of this is less than s, which is start, which is 3 here, the start. Is the end is less than the start? No, it's not. So we have an overlap, right? And if we wanna visualize that overlap, we can see it here. 4 is somewhere here, 4, and 8 is somewhere here. Yes, there is overlap, right? Like this part right here is overlapping. Now, how to fix this? So we can do like, if this fail and this fail, else, then we do it just else here. Else. Because if this fail and this fail, that means we have overlap automatically. It's like, if I can't add this.
The else. Okay.
Yeah, so I have if, else, else. It's like, can I add this at the start before this? No. Can I add it before? No. Okay, so there is overlap. You know what I mean?
I get you.
So now that we have this else, which it detects the overlap, now how we can overlap, like how we can merge them? We did see it before, right? So if we design 4 8. How we can merge this? We're just gonna put this here, gonna push it up, this gonna be red, this gonna be red, and this gonna disappear, and it's gonna become 310. Now how we can do this with the code? Now here it makes sense, it's easy, just push it, remove, and the here is overlap, fix it. We can imagine it, right? We can just try to imagine it and see. So so let's say this is gonna fix our overlap. So we're gonna see the minimum of between the interval, the minimum between the start of both of them, with 3 and 4. 3 and 4, the minimum is 3. But we're gonna put 3 here. And we're gonna go far to the end, which is 8. And we're gonna compare it with 10. Now I don't know how we're gonna do that. How are we gonna detect 10? Do we keep looping? We need somehow to detect 10.
The thing is, sorry.
Yeah.
So when you do 3, 4, you compare. You've gotten the first one. You need to move further, right? You need to move the loop further until when it gets to the first. You have to compare 8 with the first. So you have to keep comparing for the first ones to see the ones that that is less or equal to. Then you add it. You understand?
Okay.
That's more than or equal to, something like that. So you add it to the new list, then you move. Then you add it to the. You get what I'm saying, right?
It's like you are fixing the merge between this, then we loop this, then you fix the merge, then you loop this, then you fix the
loop
merge.
again, yeah. Fix the second, the ending part, the ending part. Yeah.
Okay, let me try to do that with like visualization. So we said this is our the tenders we want to merge, the value. This now we can see the overlap. But because the way the program is like looping on each interval, we can't see this. We can't see in future that, oh, there is overlap in here. We only see this one. So we're gonna compare 4. So this is 8, right? We're gonna compare 4 with 3, right? And we're gonna take the minimum of 3 and 4. And we're gonna do 3 because it's become the minimum. And when we're gonna go to the max, we're gonna compare 8 with 5. We're actually not gonna compare it with 10 because we don't see it. We only see this. Now 8 and 5, we're gonna take the max of 3, 8 and 5. And this gonna become 8. Now 3, 8 is gonna become the new interval that we wanna add. And then we're gonna loop here. And then we're gonna compare this with this, right? Because this is become our new interval. And we're gonna do the same again. We're gonna do the same rule, like we're gonna start from the beginning. We're gonna do is the start of this is bigger than the end of this, which is 7. Is it? No, it's not. So this condition is failed. We go to the else if second one. Is the end of this, which is 8, is less than the start of this? No, it's not. 8 is bigger than 6. Okay, so we have overlap again. Okay, we're gonna do the same thing we did before. What was it? We're gonna take the minimum of these two, which is in this case 3. So this gonna stay 3. And then we're gonna go to 7. And we're gonna compare it with 8. And we're gonna take the max, which is 8. So this gonna stay 8. And then we're gonna loop again. Now again, we're gonna do the same thing. We're gonna compare we're gonna compare the start, which is 3, is it greater than the end. So is 3 greater than the 10? No, it's not. So this is false. It's not gonna enter here. It's gonna go to second check. Is the end of this interval is bigger than is less than the start? Is 8 less than start? It's not. Right? Even they are the same, they are equal, right? 8, 8. So they are not less of each other. So there is an overlap. But in some problems, this may be not a case of overlapping. They might accept it. So it depends on the problem we're solving. But in this problem, we know this is an overlap case. So is the end of the interval that we're gonna add is less than the start? No. So this case is also false. So we're gonna go to else one where we merge. If we go here, we merge. Now the merge, we know it's gonna be taking the minimum of this and this. So the minimum between 3 and 8 is 3. It's gonna stay the same. The minimum between the max between 10 and 8 is 10. So this gonna change. Okay, 10 gonna become 8. 8 gonna become 10. Okay, we're gonna go to the next element. Now the next element is 12, 16. We're gonna compare again from the start right here. Is the start, which is a 3 here, is greater than the end of the element, which is 16, the end? Greater? No, it's not. So we're gonna jump to the second case. Check the end of the new element, which is 10. Is it less than the start of this? Is it less? Yes, it is. 10 is less than 12. What you're gonna do here, you're gonna append the new interval, which is in our case this. So this is a new interval, we append it here. So it's gonna become 3, 10.
Okay, sorry, please.
Yes.
Sorry.
Yes.
After the match, like, why can't we just add the rest to and return it? Is there a need to start going further, or what do you think?
Because
we've already matched it. I mean,
yeah, but notice when we merge here, the value wasn't 10. It was 5. It was 8. So if we return it, we're gonna return 8. So it's like we merge it, but we are not sure is it overlapping with futures numbers. So we need to make sure that it's actually not.
Yeah.
You know what I mean? So, example, if this is merging, if this overlapping, this value, right? If imagine this green line and this orange line, they are overlapping. So we can just merge them like this, and it's fine. But what if this orange line is overlapping with all of them? Right? So somehow.
Yeah, I get you. Thank you.
Yeah. Now we did 310 here. We added because it entered this one right here. We add 310. What will be next? So normally we should add 12, 16. Okay, so this is the case where we discussed that we can append the new interval and add the rest of the array. Add rest of array. Right? That's what we did. Because if we add it here before, then we just add the rest of array. Okay. Did you get this one? Let me try to repeat slowly. So, okay, let me lead this one here. Let me remove this. So we were like checking we had like 310, right, in new interval, and then we reached the last interval that we're gonna compare. And when we were like, okay, so let's start from this, let's compare it. Is the start is greater than the end? Is 3 greater than 16? No. So automatically we didn't enter here, and we go to the second check. Is the end less than the start? Yes, 10 is less than 12. Okay, what I need to do, I'm gonna do this. I'm gonna append new interval, which is this one. Okay, here is it, 3, 10. What else? Add the rest of the array, which is this one. Because maybe there is more here, right? Maybe there is 13, maybe there is like 19, 20, and more intervals, right? But we don't care because we are sure that 310 is finished here. So if we add the rest, it's gonna be 12, 16. If we notice the outputs we're supposed to give, it's actually the same. 1, 2, 3, 10, 12, 16. So like the algorithm is working by using this tree rule. Okay, who have like a question or something not clear in the pseudocode? Because if you understand the pseudocode, like how this works, you can code it with C, with JavaScript, Python, it doesn't matter. Any question? If not, let's go to the pseudocode or like the coding. Okay. Don't be shy. If you have a question, you can type it in the chat. We are all here learning. I also didn't know this, by the way. Like I did this problem before, so I am kinda know how solution work. And there is many solutions. So if you felt like how did you get this idea, or is it, that is total normal. Sometimes you're gonna be in problem and you're gonna think you're not gonna have idea. It's okay to ask ChatGPT or check solution of other people, learn from it. Okay, let's keep going. How we can convert this algorithm to a code. I wanna shrink this, but for some reason it's not shrinking. Okay, so the code gonna be what? So we have a new array here. Okay, let's create new array or result. Call it result. It is an array. It is an empty array. Now, how did we start our algorithm? We have these 3 cases. And we start from the first element, right? So we kinda did loop. We keep looping. So we're gonna have a for loop. For, let's call it interval. In what? Intervals. Yes. In intervals. Okay, so now we have, let's just call it enter, so don't have a lot of space. So each interval we are looping through with it, on it. We're gonna do this comparison. The first comparison was the start. The start is red, so let's do it here. The start, or like new start, new interval start. We do new s, which means the new interval that we're gonna add, the start of it's gonna be interval. It's gonna be new interval. I don't know. Maybe we don't need this. Okay, let's just go code this and then we can maybe optimize it. So my idea is like we're gonna loop on each number and then we're gonna compare the start. If we're gonna check if it's greater than the end. But what is the start? Start is new interval. Right, if we go here, the start of the new interval that we're gonna add. And it is an array, so the start is gonna be index 0. So if new interval index 0 is greater than the end. The end of what? Of the interval that I'm in. Right here.
Yeah.
So
That'll be inter 1.
yeah, let's do it like this, because it's gonna take a long space. So the end is gonna be enter index 1. We're probably gonna need also the start, so let's put it here. Start, enter 0. And okay. Now if this new interval is less than the end, what do we do? Sorry, greater than the end. We said we append interval. Okay, how we're gonna append it to result? So append interval. So results append. What we're gonna append? We're gonna append the new interval, right? So new interval. No, append interval, not.
Oh, it's interval. Inter, yeah.
Yeah, okay. Append interval. Okay, here is it here.
No, inter.
Oh, enter, yeah, I changed the name, okay. Because I did interval here. Okay. Now this is gonna be inside the if. Okay, and we have another if, or else if, not sure. I guess when we append this in interval, the loop should stop, right? Or it doesn't stop.
So that would be else if maybe.
I think it will stop, then we start from the beginning again with the next interval.
Okay, so else.
So we ask the same question again.
Okay, so we're gonna do. So it doesn't need to go here. So probably else if.
Okay.
Which means the else if this one.
Yes.
The end is less than start. The end is less than the start. The start of this one. Wait, no, sorry. The end is red, which mean new interval. New interval start. New interval start is 0. Oh, wait. Oh, the end of new interval. So 1. Right here. The second check is E, like end. Start. So the end of the new interval, we're gonna check if it is less than the start of the interval. So this is the end of the new interval with start of which is this one, start, which is enter 0. If it is else if, what we're gonna do, we're gonna do let me zoom at this. We're gonna append new interval at the rest of the array. So result append new interval, and we're gonna append again the rest of the array. Now how we can do that? We can do we have interval. We can add interval. We can add intervals. We need index. So I don't think it will work with this because we don't have index. So maybe we use the range, like for how we can add the rest of array in this case. If it was have the index, we can, yeah.
We can use enumerate if we want the index as well.
Here, we change this to the index.
Yes, just put index, comma, enumerate intervals as a
okay.
argument.
So and it's gonna be the index gonna be here, index, like this. Okay, let me check it out. So this
yes,
is
that's how it is. That's
so how this work? It's gonna give index where? At the first or at the start?
just pass the enumerate as interval as an argument into enumerate. That's all. You've done it already. That's all.
Yeah, but like I did here index enter. Is this enter index or enter or index enter? Like if I did index.
Yes, you did it right.
Okay. Let's just do it in case someone wanna see it. So let's say list or like elements. And then we have one or like 100, 200, 300. And then enumerate. What do we give it? Do you give it
give it the list
directly?
elements?
Elements. Okay. Then we're gonna print index and elements. Run. Okay. So is index element. So in this case, let's call it this E, and this one gonna be enumerate. Baba, I think you have background noise. Please mute mic. So now that we have the index, we have access to this enter. Now how we can we do plus intervals and then we slice in a way it's gonna start from this enter, which is index. Like if I did print element index print elements index, maybe like this. No,
The other way around, I think.
like this.
We should use elements, not ELE.
Oh, element.
Different.
This is index like this. Okay, so like this we can get the rest of the array. Right? Wait, maybe not.
No, you have to put the index before the colon.
So it's like saying start slicing from this index to the end of it. Okay, yeah.
Absolutely.
Yeah. So at the first one, it gives us 100, 200, and then, yeah, okay, that's perfect. Can we, I think we can do a plus. Wait, can we do plus? If we did plus, is this gonna add it? Gonna try, I guess. If I did I have this element 2, which is 5 6, and I have this gonna be 100 200, and this 300 600. If I did print plus, what's gonna do? Element plus element 2, so it's add them, but I need to
You have to encapsulate the element 2 in its own array.
like this.
So just put, yeah, then that will work.
Run. Okay, so we can do plus, and then we add it inside array. No, this one should supposed to be inside array, I think, right? Because this is the array we're gonna add to this array. Wait, we're appending to results. Now I'm gonna append this.
This is already a list.
Okay, you know what? Let's just do it. Do it simply. Then we can optimize it later. So results. We add the new interval, right? Now we're gonna results, and then we're gonna append the interval, and we said we're gonna start from the index, which is in this case, and then colon, which mean add from this index to the end. And at this point, I think we should return here in this case. When we add all the elements, then just return results. We append this, we return results because we finish. But in this case, we didn't finish. And then we're gonna have the case where we have else, which means merge, and we say we're gonna do it like the new interval. It's gonna have a new value. It's gonna be array of min and max, and min max gonna be the start, the minimum start. So I'm gonna use main function here to like find the minimum between the start, enter, and the start of new interval. So if our interval like this, the new element that we have to merge, we want to see the minimum between these two, between the starts of both of them. That's what's gonna be the new start for the new interval. So minimum of start with new interval start, which is 0. Okay, that the minimum, and the max is also the same. Max gonna be max with the end and the new interval 1, which is the end of it. Which is so this is new interval 1, index 1, and this is the end. The end we define it here. Now we have new interval min max, and we're just gonna keep looping, right? Because as we did in example, when we had new interval, we didn't push it directly to the array because we don't know if the futures intervals are gonna be if it's gonna be merged with them or they are overlapping. Okay, what gonna do here? We're gonna keep looping, and when we finish looping, we're missing something, because we return here, but what if we fix, what if we didn't enter this case? Which in this case right here, is okay, it's hard to see. What if we merge them 310 and this was the end of the array? There's no 1216, so we have 310. When we're gonna keep looping, it's gonna merge them on 310, then the loop gonna stop. Now if the loop stop, our array is like this, right? So if the loop stop, we need to add this. We need to add this new interval here, right? Because if there is new element, it's gonna enter the second case, and second case have the append here, which it will return at the end. But when there is no element after the merge, like if the last array element was a merge, we need to add it. And because we don't want to add here, we don't want to add it here. If we did add it, then we're gonna return it not, we didn't check the next element. So after we finish the loop, then we're gonna add the element new interval, which where we're gonna add it. So we're gonna add result append new.
Can I ask a question?
Yes, please.
Thank you. And the else, the last one, the else statement where we will make a merge.
Yes.
Where did we append the new interval after the merge?
So
we will not add any action in this step?
In the results?
Yes.
So we were like, so let me try to zoom. So when we merge, when we did the merge right here for this element,
okay,
we didn't wanna add it to the results, because when we are moving through the array, we are not comparing the interval with the result. We are comparing it with new interval. So what we did is,
okay,
the merge that we did, we apply it on the new interval. So the new interval itself got go from 4.8 to 3.8, and then we move to the next element until it's become 310, and let's say there is no element to compare with, then we gonna add it. Or if there is elements to compare with, and that element is bigger or outside of the interval, then automatically gonna go to the second case, and it's gonna be added here with the rest of element. So when we are merging, so when we are merging, we don't add anything to the array until we make sure that we remove all the overlap, and the overlap can be between 3 elements. So we just keep looping, and each time we loop, we adjust the value of the new interval according to the element we did loop on. I hope. Tell me if it's not clear. Maybe I try to. Yes.
I just want to imagine the steps going after each other. So when I did a step where we merge. So now we have the new one. The loop would start again from step 1 and start comparing again.
No, it's gonna go to the next element. Let me try to do it here. 7, 8, 10, and 12, 16. So we have 4, 8. This is our element. Now we're gonna compare it with this one. We're gonna see, is 4 less than 2? It's not. So in our array we're gonna add 1, 2.
1, 2.
Because this one is bigger. We're gonna go to the second one. Is 4 is 4? Wait, what did I say? Less? No, it should be is 4 is bigger than the end. If 4 is bigger than the end or less, they are the same. If 4 bigger than the end, then we're gonna append this. Now we're gonna go to the same here. If 4 bigger than 3, the end we said. Is 4 bigger than 5? No. Right? That was let me write the rules.
The first one.
It was start bigger than B. And then second rule was the end.
The end. The pink end.
Yeah. And less than start. And this one we did append interval, and this one we did append and add register and return result. And we had else, which is merge. Now we did compare 4 is 4 bigger than end, which is end right here. No, it's not. So it's not enter here. It's gonna check here. Is 4 we are still here.
Is 5
is 4 is less than the start, which is 3. Is 4 and is
Are
4.
we checking?
Oh, it's 8. Sorry, 8. Yeah, the end. The end. Is 8 is less than start. 3. It's not. So it's not gonna enter here. So it's gonna do else, which is merge. Now the merge, we're gonna get a new element, which is 3 and 5. We're gonna merge this 4 and 8 with 3 and 5. 3 and 4, the minimum of them, we can be here, 3. And 5 and 8, the bigger one of them, gonna be 8. Now, we can't append this here directly, right? Because we're gonna move here. Notice what's gonna happen is we're gonna say, is 4 bigger than end 7, but doesn't make sense because why we are still comparing with 4 and we already have new numbers 3, 8, right?
Okay, right.
So it makes sense if we're not gonna put it in the here. So what we're gonna do is we're gonna edit the new interval itself. This new interval itself is gonna be changed from 4, 8 to 3, 8. Now that we have the new interval, which is it merged with this one, now we're gonna move to here. And notice after we merge, we just changed the new interval. We didn't push it here, we didn't do anything. We just moved to here. if there is nothing here, let's say the array stops here, right? So there is nothing to loop for, then we're just gonna add this right here and return the result, which is what we did this line here. Results append new interval and then return results after we out of the loop. But in our case, the loop is not finished, so
to start from the beginning again, right?
Yeah, we're gonna move this here, and then we're gonna compare. We're gonna compare 3 and 8 with 6, 7, which is gonna be start of this 3 with the end of this. So start with this. Is 3 bigger than end 7? No, so it's not gonna enter here. Yeah, we're gonna go to the second check. Is the end, which is 8, less than the start of this, which is 6? Is the end is less than 6? No, it's not, so it's not gonna enter here, gonna enter here. We're gonna end up in
merging
again. So we're gonna merge.
Okay.
So 3 and 6, which is less? Minimum 3, it's gonna stay the same. 8 and 7, which is less? 8. 8 and 7, which is the max?
Which is better.
So it is 8. So nothing gonna happen here. This gonna stay the same. We're gonna loop again. Now again, we're gonna do the same thing. We're gonna start checking.
Yes.
And we're gonna do
another merge.
Yeah, start with is the start 3 bigger than the end, which is 10? No, it's not, so it's not gonna enter here. Is the end 8 is less than 5, less than the start, which is 8? Is
no.
Wait, is the end 8 less than the start? No, so it's not gonna enter here because 8 is not less than 8. Then it's gonna enter else, which means we have a merge again. Now when we have merge, we apply the merge on the new interval directly. Now how to apply it? We just check the minimum of this, the start with the minimum of this, which is the small number, 8 or 3? 3, so it's gonna stay 3. Now we will go to the other side, we're gonna check the max. So which bigger, 8 or 10? It is 10, so this gonna change. Now if this gonna change, it's gonna become 10. Our new interval that we're gonna compare with in the future, it did change. Now after it did change,
then
we're gonna
it will start the full loop again from the start, right?
Yeah, we're gonna loop again. We don't do anything. The results still have one value. We're gonna move here. Now let's say this is the end of our array, right? There is no 12. It's like it's end here. The loop gonna stop, and if it stop, there is append. We're gonna append it after the loop end, which means this gonna be to return, and then we're gonna return it. Now in our case, the arrays still have elements, so we're gonna move to the next element. We're gonna move here, and we're gonna compare. Is the start bigger than the end? Bigger than the end. So start is 3, the end here is 16. Is the start bigger than the end? No, it's not. This failed. We go to the second check. Is the end, which is 10, less than the start? Start here is 12. Is 10 less than 12? Yes. Okay, so we're gonna enter here. So we're not gonna merge, we're gonna enter here. When we enter here, what we're gonna do is we're gonna append the new interval. So 310. And then add the rest of the array. Now we are here. So the rest of the array is just 12, 16. Right? And if there was more element here, it's also gonna be appended here because we append all the rest of the array. And then we're gonna return this.
Okay.
Is it clear?
Thank you very much. Yes,
Yeah, no.
it's very clear. Thank you.
So this is basically the code, but we don't know if it's gonna work. So let's see. Maybe we missed something. Who have any question? This is a bit a boring task, but it need attention a bit. Please, if you have any question, just jump to the mic or the chat and write your question.
Yeah, can you change the variable name for min and max?
Yeah.
In the else.
Yeah, I probably should do that because that's a keyword, right? It's a reserved keyword, maybe. Min, let's say it starts and where they have start and end. So we do min 2.
Yeah, you can do new min, new max as well. Yeah, that's fine.
New min. New max. And what else we did miss? Let's see. Run. We did miss this one. Append. Should do this. Run. Append new interval. It should be uppercase. Okay. Run. What's happened? Is not valid for the expected return. Oh. What? Type error 1569. Is not valid value for the expected return time. So 15 and then there's this inside array. Why it is inside array? It's probably some error here. Okay. Can we print this? Print result. What's happening there? Yeah, so I did append this and then I append it inside the array. Oh, because append it at or because this gonna bring the array inside. Oh, this is array inside array. So okay, maybe plus this. Okay, it worked, but still don't understand why. If I did the results.
Yeah, so I think the reason being is, we are getting the rest of the array, so it's still an array. So when you do append, it's like appending an array into the existing array,
it puts
like
it inside.
Exactly.
Okay, yeah, thank you so much. Yes. So we are like, we have this array, and then we are like, I'm gonna append this array here. This array have many array inside, and I'm appending this array, and then I was like, you know what? Give me the rest of this array. So what it did is it creates this array, and it's bring the elements inside. But we don't want this. We want to bring just elements inside. So I guess the plus was the key here. If I did use append, when I did plus, it's mixed only the elements inside. So it's bring this one, put it here without this. Okay. It work. Let's submit. Nice. Thank you guys. Thank you. I can't believe that this problem took us this much time. But it was hard a bit to grasp. Okay, who have any question? The last two LeetCode are not this hard, I promise you that. It's gonna be simple. If no one have a question, we can jump to the second LeetCode, which is let's see min stack. So the first one we did was insert interval because it was like the most one that will take more focus. These two are not that complicated. So we have min stack. Design a stack that supports push, pop, top, and retrieve minimum elements in constant time. Implement the min stack class. Min stack initialize the stack object. Push the elements val onto the stack. Pop, remove the elements on the top of the stack. Top, get the top of elements of the stack. Get min, retrieve the minimum element in the stack. You must implement solution with O1 time complexity for each function. Okay, so this is a normal stack, right? There is nothing changed here. It just add this function that say get min, which gonna get the minimum value we have inside stack. Let's see the output and try to see if that's what they say. So min stack push. So min stack right here. We declare min stack. We push -2. We push. What did we push? We push -2. What did it give us? It gave us null because when you push, it doesn't return anything, right? Then we push what? We push 0. Push 0. Where is it? Push 0. It's a return 1 item, null. Then we push another time. We push -3. We push -3. It return nothing. And then we did get min. When we did get min, doesn't have any argument. It returned -3. So when we did get min right here, it returned -3. Okay. And then we did pop. The pop. What the pop do? It wait. Pop didn't return anything here. Right? Pop. Does pop don't return anything? Remove the just remove. Okay. So pop is just gonna remove it. It's not gonna return anything. Remove the element on top of the stack. Okay, and then top. So in this case our stack have -2, 0, -3, and then because we did pop, so -3 gonna go away, right? So we did pop, it removed -3, and then we did top, it's gonna show 0, so the last element in stack. Let's take it to the escalator and try to understand it better. Okay, so we are here and we say we have a stack. So a stack is gonna be, let's say, array. We push -2, then we push 0, then we push -3. Now we did get min. It should check which is the minimum number. Is this one? No. Is this one? No. This one. It returned -3. When we did pop, it basically check the last. What pop do is just go to the last element and it remove it. This is our array. And when we did top is just gonna check on the last element what it is. So the last element is 0, so top gonna return 0. It doesn't remove it, doesn't change the array, just check and return the value. When we did get main again, it's gonna do again, is 0, is -2 is less or 0, so it return -2. Okay, now we need to implement this function so they can work. Who have any question? Didn't understand well the problem. Okay, or if no one have question, we can jump directly to this. So how we can do this? So is the push gonna change? The push not gonna change, I guess, right? If we're gonna push element, it's just gonna get pushed. So here in the push, we just gonna put, okay, we need to initialize stack. Now how we can do that? It creates a stack like this array.
DQ, baby.
Yeah, we can do DQ, so self stack DQ. Think like this. Now we're gonna push some elements to the DQ. Like, so DQ, think of it as just an array, it's more optimized. You can use queue and stack in the same time. Now how are we gonna push elements val to this stack? Append, right? Append. Is this append?
Is it not a push left or something?
Yeah,
No,
I
can't
forgot.
push left.
Push left.
Right.
Okay. DQ. Search with image. Okay.
I think it might be a push right, because you're always pushing to the back and popping from the back.
I think append. Append. Okay, so it's still append onto the stack, but I'm sure there is some push left, push right, something like that. So in this case, we're just gonna push self stack append, and then we're gonna append the value. But how we gonna pop? Pop, we're gonna how we can do that? I need to find out a solution. Any idea? What if we keep track? We can use two stack, one stack to keep track of minimum number when we pushing them, or we can push a tuple to keep track. So when we pushing elements, let's say pushing -2, we're gonna push -2 because it's the first element, right? When we're gonna push 0, I'm gonna push 0 and I'm gonna compare 0 with -2. The less one of them, I'm gonna put it here. And then I'm gonna push -3, and then I'm gonna compare -3 with the less of one of this, which is -3. So this way I can, when I do get main, I will just get this value. Think who didn't get it? I guess it's clear, right? Our stack will be something like this, or like let's try it. Right. Oh, we're gonna push -2, right? We're gonna do -2, and and what is the minimum is 0. I'm gonna push it here 0. Then I'm gonna push 0. Then I'm gonna compare this 0 with the elements before, because it's array, I have access to this element. If it is less, I'm gonna keep it this like if it is less than itself, or like less than this, I'm gonna put it here. If it is same or that, we're just gonna keep it. In this case, we're gonna push -3. Wait, why 0? What I'm doing? Not 0, right? Because it should be -2. It is the less element. I don't know why I did this. Okay, so we push -2 because the first element, automatically the minimum gonna be itself, right? But when I'm gonna push new element, which is 0, when I'm gonna push it, I'm gonna add here I'm gonna compare 0 with -2, which is the less element. It is -2, so this is gonna be -2. I'm gonna push -3. I'm gonna check the less element here. Which one is less? -3 or -2? -3. So if I call get main, I'm gonna get the last element and get the second element index 1. That is the less element. If I pop it, if I pop this one, right, and then I say what is get minimum, it's gonna get this element, the index 1, which is -2.
Okay. Okay.
So it's gonna keep tracking. Okay, let's see.
Essentially keeping two lists there.
Yeah. Or we can do two stack. Yes. Yes, go ahead, please.
Sorry, can't we use the custom pop function? Pop method in list.
Yeah, we can pop elements with the we can do list if like here we can if we wanna do list like this, then pop it's gonna be self, or like it's not a return, right? So self stack pop, right? Because we don't return anything, so we're just gonna pop it, and this gonna be the same. It's same for DQ, they are the same. Now the top.
Okay.
Now the top. When we're gonna say top on this array, it should return 0, right?
Yes.
So how we can do that?
Sorry, in the example you're using, why are you using a tuple?
To keep track with the minimum number. Now, for example, if I have an array like this and they push -2 and they push 0 and then I push -3. If I did get main, I have no way to know what the minimum value in O1. Which mean I can't loop. I can easily loop, of course, and see which one. But they said like O1 or something. O1 here. So we need to somehow track on each element we push. So we can do like 2 stack, and 1 stack we save only the minimum number, or we can use tuple and then just get it from the last element.
Okay.
This is genius.
Yeah, ChatGPT is genius. Okay, how we can do it?
Yeah, just the way you said it, Nux.
So yeah, like the top. How we can we just gonna return the last element, right? Because we're not gonna pop.
Yeah, top just returns. It doesn't pop it.
So self stack, and the last element is gonna be -1. So self stack, because top it's just like saying who is the last element in the array, and it's gonna say oh, -3 is the last element.
Yeah, but remember it's a tuple, so you'll be getting the first element,
oh, you're right. So
last element.
-1, then 0. Because we are using tuple here, so the last element is this. This is like 0, -2. I don't want to return all this, I just want to return 0. So this and it's 0.
Let's adjust that push as well. Because it's just pushing the value. We need to push a tuple.
Oh yes. So this gonna be yeah, this gonna be,
we have to check if the stack is empty.
Okay.
If the stack is empty, then you're pushing val, val. And then if the stack is not empty, you're going to do the comparison you're speaking of, where you check the last item, check if its value is smaller than the current value that you're trying to input.
Okay, if the length of stack is 0, then we're gonna do val.
Yes, sir. And then else we need to grab the last element, the last tuple, sorry.
Val, and then
minimum between the last thing grabbed, the last value of the stack, and then you check whether or not the value, just whatever the same as top, right? You're checking to see if that same kind of thing is the minimum. Oh yeah, the minimum between that and the value.
But how so here I need to check this value with this.
Yeah.
So I need access to this.
Yeah, remember how you did it in the pop? Oh, sorry, the top? It's the same code, but you're going to put it in the min.
Yeah, you could call it top as well.
Maybe we do it clean here. So last element is gonna be self stack -1. Now we
you could do self.top. You could do self.top. We already have a function that returns
self.top, yeah. Self.top, which can return the last element, yeah, and then this.
We wrap it up in the min function where we're comparing that to the val.
Okay, so let's say new val, or like new min, and then it's gonna be minimum between the last element and the val itself. If someone trying to catch up, don't worry, explain this again. So now we have new min, just gonna append it here.
Yes, sir.
Okay, let's explain this, what we did here. So what we did, okay, you know what, I'm gonna remove this. So what we did is we gonna push, right? Now if the stack is empty, we're gonna push the value, which mean in this case -2, it's gonna be -2, -2. Now we're gonna push another time 0. We're gonna check is stack empty, not okay, else. Now I'm gonna push I'm gonna append value.
No, calculate the min first.
Yeah, so I'm gonna append like the value, which is 0, but when I'm gonna get here, I will push this value, which is the minimum between self-top, which is this one, which is exactly this number right here. Oh, we need this number.
Oh yeah, you're right. We need the other one. Yeah, so it's not self the top.
Okay.
But it's similar. It's the self dot stack minus 1 and then 1.
1. Yeah, 1 1. Okay, so let's okay, so we said we're gonna add 0. So we add 0 here as tuple, but we need to add something here to keep track with the less value in the array, which means is it -2 or 0? What we're gonna do is wait. I think it didn't. Did it change screenshot? Did not. So in this case, we're gonna add val, but we're gonna add new main, which means we're gonna calculate from here, which is self stack minus 1 1. Self stack minus 1 is the last value. So let's not add this.
Yeah, calculate the value first. Yeah.
Okay, let's calculate new main. So we're gonna calculate new main, which gonna be self stack minus 1, which is this one, the last element, and index 1, which is -2 right here. So it's gonna be -2 main of -2 and the value that we're gonna add, which is 0, which equal -2. -2 is the minimum number. So in this case, we're gonna add 0 with new main, which is -2. Again, we're gonna push, for example, -3. We're gonna do the same. Minus new main gonna be self stack of -1 1, which is last element in array is this one. 1 is -2, so it's gonna be -2 val, which is -3. Minimum of this is -3. So when I'm gonna push -3, I'm gonna do -3. Now if someone call the get main function, it will, what it's gonna do, we don't know what it's gonna do, but I guess it will get the last element 1.
Yeah, when you do get min, you just you take the last element and then you check what the minimum is.
So here we're gonna return self stack, so it is the same as this. It's gonna be it's gonna be 1.
Yes, sir.
Okay, who have a question? Who have any question? Let's run it. Ooh, submit. Ooh, nice, guys, nice. Okay, who have any question? No one? I guess continue with the last LeetCode, or do we end here? We can do one of the LeetCode because we have 3, and Sunday we're gonna just do 2, so maybe we're gonna keep it in Sunday and do these 2. So tomorrow we can do this 3.
You still have energy.
I still have energy.
If you're tired, we can call it.
No, I still have energy. We can keep going. But I felt like maybe everyone here they're tired because this one are like they are taking so much brain power to like it. Do we continue? Okay.
I vote yes.
Let me create a vote. Let's continue, and we can do it later. Just react with start on which one you want. Two. Okay, react 4, 5, 6. Oh, say what more? Who more? Okay, we can do it later, I guess. Okay, 4 is comeback. There is a comeback. We keep the vote going. Okay, 6 win, I guess. Okay, guys, we end it here. It was a tired session, but I guess that's what LeetCode does. It's medium difficulty, so it will take some time. Okay, have a good night. But before that, remember to join tomorrow, and let's do this one that we didn't do today, and the matrix. And if we have energy, we can keep going do this. Okay. Thank you, everyone.
Thank you. Have a good night.
Good night.
Peace out, guys.
Peace, niggas.